Okay, in this lesson we're going to talk about position and displacement. You're going to learn to define them, you're going to learn to calculate displacement given a situation, and you're going to learn to tell the difference between the two of them. So position is just defined as the location of something relative to the origin. So we're going to define some sort of place in space and call that the origin, just like you would in math, and then we're going to measure something's position relative to that. And the position includes both how far it is from that origin, and it also includes the direction. And we'll see soon that that's important. Now, position gets different symbols depending on which textbooks you look at. We're going to use the symbol X, and we're going to put a little half arrow, or you could use a full arrow if you want, on top of that, and we'll see in a moment what that means. Other textbooks or other places you look might use D, they might use R. Position gets different symbols, but we'll use X like this. And because we're measuring how far something is, we're going to use the SI units of meters. So position is the location of something relative to the origin. That's the symbol, and we measure it in meters. Displacement is just the change in position. So if something moves from one place to another, its position changes, and the displacement measures, again, both how far it has moved and the direction in which it's moved. So because it's the change in position, its symbol looks similar to the symbol for position. We're going to write a delta in front of it. That delta is a new symbol, and it means change in, so that's a new symbol for you. Delta means change in, and delta, then we put X like this. So this means, you read this as delta X, and it means the change in X, or the change in position. Now, that's therefore defined as the position at time 2, which I'm going to write as x sub 2, subtract the position at time 1, so minus x1. You could also use, some people will write x sub f for final, minus x sub I for initial, the final position minus the initial position. Okay, so displacement is just change in position, and therefore it's also going to be in meters. Again, displacement, just to give you the full definition down here, delta x is equal to x2 minus x1, or x final minus x initial. Position 2 minus position 1, or final position minus initial position. And that little arrow that we've been putting on top, this arrow here on top of the x, that indicates a vector. And that's something that has both a quantity and a direction, and we'll learn more about those in a future lesson. But anytime you see that little arrow, it means the thing underneath it is a vector, something that has a direction as well. Okay, let's look at some examples. We'll use the same kind of example we used in the previous lesson. If I'm playing fetch with my dog, and he's here with me at the 0 position, and I throw the ball, and he runs 12.5 meters this way, and so we'll use right on the page. I'm going to imagine that right is the positive direction. If right's the positive direction, then that means that left is going to be the negative direction. And so if he ends up over here, then his displacement, delta x, which is equal to his final position minus his initial position, is going to be 12.5 meters minus 0 meters, and that's 12.5 meters. And I said it includes a direction, so we're going to put the direction in square brackets, and that's 12.5 meters right. Okay? What if I had started here at 0, and he had started at 3 meters away from me, ready to go, and then ran out to 12.5 meters. So in that case, we just subtract again, but now I'm subtracting 12.5 meters minus 3 meters, and that's 9.5 meters. Again, I'm not interested in where he ended up. I'm interested in how far he's traveled, and he's traveled 9.5 meters to the right. Okay, I just want to point out that one way of thinking about this is to draw an arrow that starts where he starts up here, and goes to where he ends and measure the length of that arrow. And in this case, it's 12.5 meters and it's pointing to the right. And in this case, it's 9.5 meters. And again, it's pointing to the right. One more example. Let's say now I start over here and my dog starts with me. And I throw the ball in this direction and he runs 9 meters in this direction, and then he turns around and he runs back this way and he ends up 6 meters over here. And I'm going to put negative 6.0 meters because I've made right positive. So now he ends up back here. So in this case, the displacement again is equal to his final position, 6 meters to the left, minus his initial displacement, which was 0. So I get negative 6.0 meters minus 0, not minus 9, minus 0 is equal to negative 6.0 meters. And you'll see this kind of thing, the final answer is reported in different ways. Sometimes it'll be left as minus 6 meters. If we know that positive is to the right, then that means it's left. Or it'll be written as 6.0 meters to the left. Okay, so again, another example showing that it doesn't matter the total distance he's traveled, right? Because here he's gone 9 meters out, then he's gone 9 meters back for a total of 18, and then another 6 meters to the left would be 24 meters of total distance. We're just interested to know what his displacement is, and his displacement is 6 meters to the left of where he started from. Okay, so those are all examples in 1 dimension, but the same holds true in 2 dimensions. Let's say you start here at position 1 and you travel to position 2, and you do it by a very circuitous route like this, and let's say that that total distance is 20 kilometers. Your displacement, however, is just your final position. This is position 2 minus your initial position. And so it's that straight line, and therefore the displacement could be, I don't know, let's say that's 8 kilometers, and in this case, we'll say that it's to the east. Okay, so again, displacement, final position minus initial position. Similarly, if I start here and I walk around in a big loop, and let's say that loop is 100 kilometers, but I end up back where I started from, it doesn't matter my displacement, is just my final position minus my initial position. Those are the same. My displacement in this case is 0. Okay, so keep that in mind. So distance, if we were to explain it in words, distance is the total ground covered. And so in the example on the top left here, it's the length of that curvy path, the curvy dotted path. Whereas displacement is the change in position. And it's going to be measured relative to the origin, and it includes the direction. Okay, so that's the difference between distance and displacement and how to calculate displacement. Thanks for watching. Time to practice.